Hi, and welcome to a demo of Elastic GPU service from Avacia. I'm going to walk through our Elastic GPU service dashboards and show you how we dynamically allocate GPUs to multiple workspaces and teams across Kubernetes clusters. The first thing you'll notice on our dashboard, we have a high-level heads-up view of all of the resources that are currently assigned to Elastic GPU service. You can see that there are 5 total GPUs in the system, and currently all 5 of those GPUs are allocated to various jobs. As we move to the right and look at GPU utilization, the utilization is currently running about 64% of the total capacity of the system. That means we're actually wasting about 36% of the GPUs that we have. As we continue to the right, we can start to see which teams are more efficiently or less efficiently using their GPUs. The Pepsi team is using about 92% of their GPUs, so that's pretty good. The Coke team is using almost 60%. Not bad, but some room for improvement. And Team B is way behind with only 16% of the GPUs being utilized. We probably need to speak to Team B to see if they can improve their utilization or make better use of their GPUs or return some of the resources back to be used by others. Continuing, we can see our workload distribution by GPUs. These are actual jobs running on the GPUs and gives a good visibility to which jobs are assigned to GPUs. Then we get a heads-up display of the GPU utilization by GPU. So we can see that these H100 GPUs are running a little bit lower, maybe 19% utilization. There's another 19% H100. But this RTX 4000 is running about 90% utilization. So it's another way to go through my inventory of GPUs and discover which GPUs are being used to the best and which GPUs have room for improvement. We also look at various priorities of jobs that are currently running in the system. And this will become important as we look to how we can take over capacity that may be not used to its best extent or needs to be reprioritized to different jobs. Now, not only can we look at the actual workload allocation and utilization, we can look at the cost that's associated with all of these workloads. So if I look at the month to date, I can see that we've spent about $607 on GPUs so far this month. Of that, about $169 was actually allocated, meaning that I wasted about $438 worth of GPUs because I hadn't allocated those to jobs. This is a big signal for CIO leaders to get a handle on their current GPU spend and how much of it is being put to good use. Now, even within that $169, if I further break it down and look at the wastage of what part of that $169 did I actually use versus not, well, it turns out this setup only used about $17 worth of that entire $607 allocation. That represents a large wastage and definitely room for improvement. I can again look at the different teams and how much of that total did they use on a team-by-team basis. I can look at the categories of my cost, whether that was CPUs or GPUs. I can look at trend analysis over time to see how my spend varied since the beginning of the month or earlier in the month. And I can also get a very granular look on a per workload basis as to which workloads consumed the most cost on a given month. So this first job was using almost $9, was using $9.24, whereas some of the other ones are using $1.75 and $1.27. This is a level of visibility that just doesn't exist out there in terms of utilization and really tying it back to an individual job to get a sense of what that cost is for that specific job. From the cost, we can continue to move down and look at the infrastructure health itself. So these are the actual GPU chips running in my system. I can again see the different types and how much power each is using. So 460 watts, and another one using about the same amount, 460 watts, and some lower usage, 118 watts. But these are lower power GPUs too, the RTX 4000s. So this gives me a high level view of how much power I'm using. I also get temperature readings from all the GPUs in my system. This is really handy for on-premises deployment, where you may want to monitor the temperature of your GPUs to improve reliability and enhance lifespan of your GPUs. We can also look at power over time on various compute instances that may be assigned into my various clusters. You can see that over time workloads are coming and going, so I get a good sense of how much power I'm using over time, and again, how that temperature is also varying over time for each of the instances that may be running various jobs. I can look at my memory. I can look at my jobs per dollar per watt for each of the workloads that are running, and I can even look at memory trend analysis on a per node basis to see if any of my nodes are experiencing unusually high memory utilization. Next, we're going to look at the workspace concept and how we assign GPU resources into workspaces. So to do that, I like to first start with our inventory just to see what types of GPUs we have in the system and where they're currently located. You can see that we have 5 different GPUs. So Elastic GPU Service can look at different types of GPUs all within the same system. It doesn't have to be only one type of GPU. We can look at lots of different GPU types. Likewise, we can span across clusters. So if you have multiple Kubernetes clusters that you're trying to manage, you can look at each cluster in turn and the associated inventory in each of those clusters. You can also have a view of how many GPUs are allocated versus how many are available. In this case, all of our GPUs are allocated, meaning there's no more space, and maybe I have some additional jobs that are going to want some additional capacity or prioritize some of the capacity. How should I do that? Well, we'll get there in just a minute. We're going to jump over to our workspaces. So now that we have the inventory, we're going to look at how that inventory can be applied to workspaces. For instance, I have several, we could call these teams, we could call these groups, we could call these projects. And each of the projects, let's click into Pepsi for instance, will have a number of clusters associated to it. So in this case, we have 2 clusters, one up in Nebius and one up in Akamai. They're both healthy and they're assigned into the Pepsi workspace. Likewise, for Kubernetes namespaces, we can also assign namespaces into workspaces. And this allows us to deploy jobs into any of these namespaces and have them delivered out to the clusters that are assigned to my workspace. Likewise, on the Coke side, we can also see the number of namespaces that are assigned to the Coke team. There's a backend here, and there's a couple of other Coke namespaces that are spreading across clusters. This is all very useful for managing workloads. And make sure you're dividing up your projects and your teams and getting the best use of your infrastructure. Now, where the magic comes in is when these workspaces get assigned GPU capacity. The way we do that is through GPU requests. GPU requests give us the ability to take GPU inventory from our GPU inventory and assign that inventory to any workspace that's part of EGS. So you can see here, I've got 5 different provision GPUs, and they're into many different teams. Team B is using an H100. I've got another H100 being used by the Coke team. I've got an H200 that's being used by Coke, and Pepsi has both of the RTX 4000s. Now, if you remember on my dashboard, my Pepsi team is getting pretty close to maxed out on their allocation. And let's say I just got a call from the Pepsi team leader that says, hey, I need some more capacity. I'm running out and I have an additional job to execute, but I just don't have space in my current allocation. Well, as an administrator, I can look maybe to the next team that has some free capacity. Let's say the Coke team. They're only using about 60% of their utilization. Let's go look at their workloads and see what we can recover in terms of capacity. So if I go to my AI workloads and look at Coke, I'll see that they have one backend predictor running, and they have a stress test running on an NVIDIA H200. Now, the Pepsi team has specifically told me they would like to have an H200 capability because they need the additional memory that's available on that particular GPU model. So in the old days, I might have to call the Coke team and get them to spin their job down and recover that capacity and create new logins and new clusters. But with EGS, I don't have to do any of that anymore. In fact, I don't even need to contact the Coke team. I can simply go to create a new GPU request that will switch this H200 from Coke. It essentially can preempt this workload and reassign it to the Pepsi team so that they'll have access to this H200. Now, how that works is I go create a new GPU request for the Pepsi team. They're saying, I need more capacity. So I'll create that GPU request. I'll maybe call it an H200 recover or from Coke. Great. I'll select the amount of memory I need, but oh my gosh, I'm just noticing I don't have the big enough GPU here. That H200 hasn't been added to my workspace as a potential yet. Well, let's go see how easy that is to add through the workspace concept. In workspaces, I simply navigate to my Pepsi workspace, and because I've got 3 clusters in the system, right now I only have cluster 2 and cluster 3, I can very easily go in and add the cluster that I know has the H200 in it. And I save that workspace, and the workspace is updated. It's that easy just to add additional capacity potential to my Pepsi workspace. So now when I go back into my GPU requests and create a new one for Pepsi, I'll see that I have all 3 clusters as potential targets. I'll see my current 2 RTX 4000s, which are already provisioned, and I'll be able to create a new one. What did we call that? We said get an H200 from Coke. This can be any name. Now I'll see that I have the big guy available, 140 GB H200. That's great. That's exactly what the Pepsi team needed. So I'll assign that GPU. The system is aware that these clusters don't have that type of GPU memory, and only this worker Nebius cluster has the additional memory that I'm looking for. So I can add that cluster. Likewise, I can say how long I'd like to reserve this. Maybe it's for 3 days, or 1 day, or just 5 hours. Maybe that's enough to get my work done. Here's where the magic comes in. Now I can select the priority that I'd like to execute this job. And the Pepsi team has told me this is a pretty high priority job. So I'm going to pick high. That boosts the priority of this request above the request that Coke had. There's additional configuration options here. If I'd like to time out if my job goes idle, I can set those, and I can also requeue if there's a job failure. I have some additional options, but we don't need those for this request. I'm just going to get the wait time, which is going to tell me that I don't have any wait time because I'm a high priority job, and the system knows that this H200 is only running a medium priority job. I can put that request in right away. And what's going to happen is you'll see the request get queued in the Pepsi account. So Pepsi is now queued for this H200 device. If we flip back over to Coke, we'll see that their H200 that was running just went back to queued on their side. That means that this job has been evicted or preempted. We freed that H200 up. All the workloads that were using that device were paused, and space was made for Pepsi to come in and get a hold of that H200. While that's coming through, we'll switch over to the Pepsi workspace and get ready to take advantage of having this H200 available to us. So let's check our context. Let's check our namespaces. We're in Coke. We need to switch over to Pepsi. We don't have any workloads running yet, but we're about to launch one. And we have a convenient little stress test that we can deploy just to exercise this GPU. And what you'll see is the H200 has now been assigned to the Pepsi workspace. So this workload that I just deployed should be running. And it is. It's just getting ready through the pending state. All of these operations are very easy to move GPUs between workspaces, to reconfigure workspaces, and to execute jobs in many different workspace environments, making the entire EGS process low friction, easy to adopt, and helps you to get the best out of your GPU utilization. Thank you for your time, and I hope you enjoy trying out EGS.